So let's start. So if you ask a non-Java programmer, do you know Java? So he's going to ask what? What are you talking about? So if you look at the development time required for Pig, 10 lines of Pig statements would be 200 lines of codes in Java. Okay, so that is what is the significance of making something as very small. Okay, plus the biggest advantage of Pig is that it has got a lot of inbuilt operators like a join operator, group, filter, sort, etc. So you don't have to write a code for that. So the default operators are always there. So that is what is advantage. So you don't have to learn Java at all. Okay. Abhishek Sawant was saying, are Pig, Hive do the same job or do they do different? Okay. So what does HDFS understands, Abhishek Sawant? Only MapReduce. So either you can do a traditional MapReduce code, which a Java developer will do, or if you don't know Java, if you like more of scripting, you can start with Pig, wherein you will do a scripting approach. And if you are more from the SQL world, you will use Hive. So all three of them do the same thing, but then it is giving you the choice of how to go about doing it. But then there are some limitations, there are some strings attached to it. So like for example in Hive, you can do only structured data. In Pig, you can do both structured and semi-structured data. You can't do unstructured data, whereas in MapReduce, you can do anything. So that is the difference at a very high level, Abhishek. Okay? Hope that makes it clear. And after today's session, I would want you to very seriously look at the examples as well as look at the Hadoop Definitive Guide for Pig. Thank you. So let me move on. So why was Pig created? When we already had MapReduce, why did you need Pig? So Pig was actually created by Yahoo. So they had a lot of ad hoc work that needed to be done. They wanted it to be done on the client machines. That means they didn't want people to log on to the cluster and do things. So this was their two primary requirements. So Pig was created because you wanted an ad hoc way of creating and executing MapReduce on huge data sets. Okay, and if you're having non-Java programmers, then that is a very big challenge trying to do that. They wanted to do it in a RAD fashion, rapid application development fashion. They didn't have the Java guys. Okay, they had people who knew more of scripting. Okay, so that's why no Java is required, and that's why it was developed by Yahoo. So when I say ad hoc way, what do you mean by ad hoc is, what do you do typically in OLAP? You will have some kind of standard reporting, right? So if your reports are known at the end of a week, or at the middle of a week, or on every Thursday you want some reports to be done. So the reports are all standardized. So that is what is typically reporting. But ad hoc is the opposite of reporting. When I don't want to do something, I see that there is a sudden surge in something, or there is a need, what happens, and you want to analyze it at that time. That is what is the meaning of ad hoc. Okay, so Hassan had asked me, can you just revise ad hoc? So this is what is the meaning of ad hoc. Okay, that means it is not in a structured way. That means it is not scheduled. It's not like reporting. So this is the reason why Pig was created by Yahoo. So if you look at Pig, so again a quick description of what is Pig. We have seen it as what it is. It's an open source high-level data flow system. It provides a simple language for queries and data manipulation. The language is called as Pig Latin, which is compiled into MapReduce jobs that is going to be running on Hadoop. Why is it important? Because companies like Google, Yahoo, and Microsoft are collecting huge amount of data sets in the form of clickstreams. Clickstreams means where do you click on a web page once you log into it. Looking at your search logs and web crawlers. Web crawlers are nothing but the complete set of files, how you are. It's something similar to your clickstreams. Search logs is nothing but your error logs. So a lot of analysis is happening on these kind of semi-structured data nowadays. So some form of ad hoc processing and analysis of all of this information is required, although there is nothing like reporting. Okay, reporting is typically done on an OLTP data. So that is what is the advantage of Pig, or that is what is Pig, friends. So let's start. So like I said, Hive was started off by Facebook. That was a time when Jeff Hammerbash was there, and for people who have read your Hadoop Definitive Guide Hive chapter, you will see this was founded by in Jeff Hammerbash's time when he was as a part of Facebook. Now he is a part of Cloudera. Okay, so in those days what was happening is that the data was getting what Facebook 2009 I'm talking about, the data that Facebook was getting was very huge, and they wanted to look at different ways in which how they can store and they can mine or they can analyze that particular data. And they heard a lot of stories about Hadoop, but then the problem was that Hadoop needed Java programming to be done, and they had a lot of PHP Python guys and people who know SQL. So they wanted something wherein people can do analysis using SQL on HDFS. That was not there in those days. Okay, so that's the reason why Jeff Hammerbash put in a team to create this Hive component, and then he had open sourced it. Okay. Hey, Sagar was saying my network was down. Did I miss any important thing? Sagar, you missed the demo of semi-structured analysis using a log file, and we are just starting with Hive right now. Okay, so you can look at your recording, Sagar, and you should be back on track. We are just starting with our first slide on Hive. You're lucky, but you missed the whole section of semi-structured analysis using Pig. That's okay. Not major, Sagar. Cool. So it was started at Facebook. Data was collected via nightly cron jobs into their Oracle DB. ETL was typically, like I said, hand-coded Python. ETL was there because ETL is nothing but extract, transform, and load, wherein you will extract the data from multiple data sources, you'll transform it, and then you will load it into a common source. And the way the data grew from 2006 to about 1 terabyte a day in 2007, it was about 10 terabyte in 2012, and in 2013, early 2014, it's about 25 terabyte of messages. That is the way how the data size has been growing in Facebook. Okay, so this is the Hive background, friends. And we have already seen how to start with a terminal with a putty. Okay, open up putty, and you will have to set up, I hope, Sagar, you have set up your Hive on your Cloudera. You will type sudo hive, and when you say show databases, it should show you OK and default. Perfect, friends. Fine. So what is Hive? It's a data warehousing package that is built on top of Hadoop. Then what is the purpose of it? It is primarily used for data analysis. It is targeted towards users who are comfortable with plain SQL. It is similar to SQL and is called as HiveQL. It is for managing and querying only structured data. So this is where differences come in. So what is the purpose of Hive? Since we are using a SQL, so that means rows and columns, that means it can be used only for structured data. You cannot use Hive for semi-structured and unstructured data. Okay. Next thing is it abstracts the complexity of Hadoop. Very true, because you don't have to write a MapReduce program. Again, I see a lot of people liking this. No need to learn Java and the Hadoop APIs. You're not going to write a single MapReduce code again today, Hassan. Okay, and it was developed by Facebook and contributed to the community, and Facebook has analyzed several terabytes of data every day using Hive. So now if you look at the Hadoop Definitive Guide, all of you, in the Hive chapter, there is a comparison between your SQL and HiveQL. I would sincerely recommend you to go through each of those links and see what the differences are sometime this week. So if you have any questions, you can ask me next week. But then that is must for you, friends. Fine? So this is the basics of Hive. Okay, Hassan, sorry. Today in the morning, I have another student in the morning batch who is a non-Java programmer. His name is Rajiv Goon. So I got confused between Hassan and Rajiv. Okay. So Aditya was saying, so what is the Hadoop picture for your this? Derby is not a Hadoop part, right? So, you know, Hive is like a beehive. So Derby doesn't have a picture, friend. Cool. So Hassan, you are also a Java guy, right? So non-Java programmers would love this. Java programmers, of course, knows your plain Java code, and of course, they can excel in this also. Cool. Cool, Aditya. So Abhilash was saying we are pointing to a directory because we are using local. Hey, by default, it will always have to be pointed to a directory where it can be stored. So since we are using embedded Derby Metastore, it has to be either a local directory or it could be a shared network directory also. Exactly. Even in a cluster, we will point it to one of the machines where the database would be. Fine, Abhilash. Now let's move on. So what is Hive? It defines SQL-like query language called as QL. We will see hands-on on it very soon. Okay, it is like a data warehouse infrastructure wherein you'll dump everything into a data warehouse. It provides tool to enable easy data ETL, extract, transform, and load, and it allows people to, developers to plug in their custom mapper and reducer code so that whatever is your custom scripts that can also be executed, you can plug in your custom mapper and reducer code. This is what we'll be seeing next Sunday in our advanced Hive in our module number 7. So now let's compare Hive and Pig. So what is Pig? Pig is a procedural data flow language. You know that, whereas Hive is a declarish SQL language. So yesterday you saw how to pick something. You will say A is equal to load my data, dump A. Here you will say select star from my table. Then who is going to use Pig? Pig is going to be used by programmers and researchers because it is not for reporting, whereas Hive is primarily going to be used by data analysts and it is going to be used for reporting. So that's the difference between a Pig and Hive. Okay. Another difference, Pig is on the client side, Hive is on the server side, on the cluster and the fourth difference would be your, suddenly I forgot, no, client and server we have done. One more difference I had thought about. No, it's not coming to my mind. There's another slide which will talk about more differences, guys. So just let's focus on these three different. Hey, that's right. Good, Janardhan. That's what it came to my mind. Then I lost it. Pig is basically for semi-structured data, and Hive is for structured data. Trust me, that's exactly what I wanted to say, but then I lost it. Cool. So Aditya was saying, can Pig come before Hive? Pig output be used by Hive? Why not? See, all of them are individual, and where is the output of all of these things stored? In HDFS, right? So as long as the data is in HDFS, you can use any tool to pick up the data. Fantastic. So now there we go. See, this is the slide I was talking about. A much more detailed breakup of the differences between Pig and Hive. First, language we have seen. It is SQL-like, it is Pig Latin. If you talk about schema, in Hive you have to create a table, whereas in Pig we never created a table. We just said as so and so. So it is a kind of an implicit schema over there. Here we had to create a table specifically. If you look at partitions, okay, in Hive you can create partitions. In Pig you cannot create partitions. If you talk about a server, Hive has got something called as a thrift server, using which it can have other applications communicate to it. It is called as Apache Thrift, which is a RPC based mechanism, again developed by Facebook. So let me go down here and tell you what is Apache Thrift. Sorry, not developed by Facebook. It is developed by Facebook. Sorry. It is developed by Facebook, so go down to Wikipedia. It is basically for like a RPC call, language independent RPC call. There it is. Thrift is an ideal interface definition language that is used to define and create services for different languages. It is used as an RPC framework and was developed by Facebook for a scalable cross-language service deployment. So this is somewhat like Corba for people who are aware of Corba. Common object request broker architecture. So this is somewhat like Corba. Okay, so you would need something, something called as an Apache Thrift server for our, just let me close this. Yeah, we would need an Apache Thrift server for our server logic, whereas Pig doesn't have anything of that sort. UDF functions can be created in both Custom serializer, deserializer can be created in both. DFS, direct access. Okay, so in Hive we will never point to the actual HDFS folder, whereas in Pig we need that. Remember we said load / test.log today, so there would be an explicit DFS access, whereas there would be an implicit DFS access in Hive. Join, order, sort, your command line shell, your streaming, that is live data analysis, all of them are possible in both. You have a pretty good web interface for Hive that is called as HWI, Hive Web Interface, whereas Pig does not have that. And JDBC, ODBC is there in Hive, although in a limited fashion. We don't have any JDBC, ODBC in Pig. So these are some of the differences, folks. So Aditya was saying, then how are files pointed for new files? We will look at that, Aditya, once we create a table. Streaming, Janardhan, means whenever the live data is coming in, how do I do analysis of the streaming data? Streaming data is typically put in with via a standard in and a standard out. Okay, that is what is streaming. Hey, JDBC, ODBC is, I told you there's a driver, right? So Hive has got a JDBC, ODBC driver, whereas Pig does not have a driver. That is the difference, friends. Cool. You're welcome. So now the last diagram, and then we have to get into the hands-on. Yep, there it is. So